Hey everybody, how you doing? Got my good friend Tiara here with me to help talk to you about inverses. Now I know you studied inverses in Algebra 2, but maybe you're a little rusty, maybe you need a review. So first we're going to go over some basics, just the big concepts, and then we're going to do some specific examples and we're going to look at the graphs of those examples. Alright, so Tiara, taking a look over here, I have a graph of a function, no formula, just a picture. This little L-shaped piece right there. And what I'd like to do is for you to tell me the domain and range of that function.
Okay, so the domain, the x-axis, so this is 1, this is 2, 3, 4, 5, 6, 7. So the domain for this L shape, x, 1, 2, 9.
Okay, so the domain is from 1 to 9. And what about the range, ma'am?
Range, the y-axis, and x. And
Okay, now we always want to do low number then high number. Which of these is lower?
-4, -1. There we go.
-4 to -1. See, even calculus people sometimes make mistakes. That's why we practice. Okay, now over here I have a blank grid. And I'd like to find the inverse of this graph, even though I don't have a formula. Can we do that?
Yes.
How do we do that? What do we have to do?
You could
Now, what do you mean by flip the x and the y? Okay, so show me an example of that if you would. Like, show me a point on this graph.
Okay, so a point on this graph that I can see more clearly is right here.
Okay.
To be 2, 1, 2, 4. So this point is 4, -2. So
Okay.
doing the inverse of it, I'm just gonna flip my x and my y to.
Okay, so show us over here what that's going to flip to.
Okay, so instead of 4, -2, flip it, it'll be -2 and 4. So my x is now on this side, and this is 1, 2, go up 4, 1, 2, 3, 4. Now it's -2, 4.
Okay, so you're saying this point 4, -2 became that point -2, 4.
Yes.
All right. Could you do that with any other points?
Yes.
Okay, show us.
Okay. This point is 9, 4, x, y. So over here, it will now be -4, 9. This is 1, 2, 3, 4. And up 1, 2, 8, 9, all the way at the top of the graph. So now my point is -4, 9.
Cool. Could we do any more? Could we invert this entire graph over to here?
Yes.
Okay, how would you do that? What do you think you would do next?
You could go point by point. But
Every single point?
On this one, yes. You could, but that seems like that would take a while.
Are there any points that seem more important than others?
Yes.
Like what?
The ends.
The ends?
And
Okay.
then this point.
All right, what do we call that point?
The vertex.
The vertex. The vertex. Okay, so what about that other endpoint? What are the coordinates of that other endpoint?
This endpoint is -1, -4.
Okay, so then on the inverse you would have?
-3, -1. So 1, 2, 3. It's all here.
Oh wait, I think we have a small error here. This is +1, -3.
Positive? Yeah.
That's +1, -3. So on the inverse it's going to be -3, +1. Good,
Yes.
good, good.
There
And
we
you
go.
mentioned the vertex.
Yeah. This point is a little off of 7. Just
Well, let's estimate and call it 7.
We'll call it So this point is 7, -1. So over here, it'll be -1, 7, -1, 2, 7.
Excellent. And so now what about all these points in between? What are we going to do about those guys?
We can disconnect these points.
So what's that going to look like?
Here, and then here.
So this piece here
Yeah.
became this piece here on the inverse.
Yes.
Oh, okay. Now, you said you made this graph by switching the x and the y.
Yes.
Does that also mean the domain and range are going to switch?
Yes.
Okay, well, let's see. The range we used to have was -4 to -1. Is our domain now from -4 to -1?
Yes, sir.
-4 up to -1. So our domain is now what our range used to be. X belongs to -4, -1. What about the range, the domain? The old domain, is that really now going to become the new range?
Yes.
Okay, convince me.
Well, this is our start point at 1, and the end point is up here at 9. So from 1 to 9, just like here.
So y goes from 1 to 9.
Yes, sir.
So when we go from an original graph to an inverse, the domain and range just trade places. Okay. Now just to make sure everybody at home is totally following all that, let's do one more very quickly.
Okay.
Just one more. Okay, so let me adjust my picture there while you erase. Okay, so this time I've given us a parabola, because in a minute we're going to do the arithmetic on parabolas.
Right.
So now we're just going to do a picture of a parabola. So here's a parabola. I didn't draw arrows there, but it is continuing up and up and up and up and up forever.
Yes.
So what's the domain here?
X.
Parentheses, yes. So all real numbers.
Yes.
Okay. And what about the range? What's the range of this parabola?
Range is, that's on X, Y, there we go, is 0 all the way to a positive infinity.
Okay. Now, if what you told me a minute ago is true, that means when we do the inverse, the domain of the inverse is going to be from 0 to infinity.
Yes.
And the range of the inverse is going to be all real numbers. All right. Well, I want to believe you, but you're going to have to convince me. Show me some points and their inverse.
Okay. So we'll start with this point right here.
The vertex,
The
okay.
vertex. And so this is 1, 2, 5, and 0. So since we're flipping, our new point is going to be 0, -5. So okay, that's one point. And then we said it goes out into infinity since they flipped.
Yep.
So if you were to draw it, you start at the vertex and then draw out towards it along the lines.
Well, let's see. If I do that, then my domain is from 0 to infinity, and my range is from -infinity to +infinity. Well, hey, it looks like it's working. All right. So that's how you work from just a picture without a graph. Now we're going to try it the other way around. I mean, just a picture without a formula. Now we're going to do a formula without a picture, and then we're going to use Desmos to check it and see if we're right. So going to our formula without a picture now. Here's a simple one we're going to start with. Y equals 2x plus 5. Right? So if you were going to find the inverse of that, what would that inverse look like? And I tell you what, if you would, we're going to go ahead and do the computations over here, so that way I can draw the graph over here with Desmos.
Okay, so if I were handling it, I would switch x and y first. So x would equal 2y plus 5. And then I would solve for this y on this side.
Okay.
The inverse. So I would subtract 5 on both sides first. Then divide by 2 to get y by itself. So y equals x over 2 minus 5 over 2.
Okay, x over 2 minus 5 over 2. So, no, that's, I think, the best way to write it. Or in other words, 1/2 x minus 5 over 2. All right, now let's see if she's right. So I'm going to hop over to Desmos here, and I'm going to put in the original function, y equals 2x plus 5.
Oh, it says minus.
Oh, excuse me, minus 5? Minus 5. Okay.
Oh, I thought you typed in 2x minus 5, but it is 2x plus 5.
It is 2x plus 5.
Yeah.
Okay, all right, that's fine.
It looks weird from
So there's my graph. Now I notice the original graph has the point negative 2.5 comma 0. So when we do her inverse, we should see the reverse point. Let's see, she says y equals x over 2 minus 5 over 2. So just a minute ago, we had the point negative 2.50, and here I have the point 0, negative 2.5, so it looks like we're doing well. Let's try another one. Over here, I have the point 0.5, and look at that inverse in blue, we have 5, 0. So do we have a good reversing? Yes, we do. Yes, we do. Excellent, excellent, excellent. Now, lines are pretty easy. You probably did lines back in Algebra 1. So what if we move to something a little bit tougher? What if we move to a parabola? Now, this one you'll remember from Algebra 2. We call this vertex form. It says y equals x minus 2 squared minus 5. That's vertex form. So if you remember from Algebra 2, the vertex of your parabola, you can tell the parabola opens up because this is positive, and the vertex is at positive 2, negative 5. Now, what about finding the inverse of that? How would you do that, ma'am?
You can switch x and y again.
You want to switch x and y again? Okay, go for it.
At this point, again, I would solve for the y to isolate it. Plus 5. Y minus 2 squared. So, since it's squared, I found the square root of both sides to isolate that. Those cancel. Okay, so the square root of x plus 5 equals y minus 2, and then add 2 to both sides, and then we have square root of x plus 5 plus 2 equals y, but since it's a square root, we have plus or minus.
Excellent.
But,
So,
I don't want the order.
well, if you want to put the 2 at the beginning, you
Yeah,
can.
the order was disgusting.
Okay, I'm okay with that order, but if you don't like it, that's fine. Okay. Now, what's really important for you to notice here, folks, is that in order to solve this, Tara had to find 2 pieces. This is actually 2 formulas that are joined together with that plus or minus. We actually have one formula that says y equals 2 add the square root of x plus 5. And we have a second formula that says y equals 2 subtract the square root of x plus 5. And if you're doing this on your graphing calculator, there's no plus or minus key. So you're going to need to do each of those separately. And when I check her answer on Desmos, I'm going to have to type each of those separately. And now that we mentioned Desmos, let's take a look. So, wrong button. There we go. There we go. There we go. Okay. So you'll remember, folks, that I told you that because we had -2, -5, that the vertex was going to be at +2, -5. And if I trace right down here, you'll see there is that point I promised, +2, -5. Now we also have a y-intercept here at -0.236, and we have an x-intercept at 4.236, and we have a y-intercept at 0, -1. Now, if Tiara has done everything correctly, then when I put her two formulas in, I'm going to see each of these points reverse its order. So for instance, 0, -1 is going to become flip, -1, 0. 2, -5 is going to flip over and become -5, 2. Let's see if she's right. So you have 2 plus the square root. And that gives us this. Now you notice that's only half the story. That's the positive square root. That's 2 plus the square root of x plus 5. Now I'm going to go over to the negative part. 2 minus the square root. And you'll see, folks, in green, there's the rest of the graph. So here's 2 plus the square root of 5 up here. Square root of x plus 5. Here's 2 minus the square root of x plus 5 over there. Now let's check our points. Our original graph had a vertex at 2, -5. Our new graph, look at that, -5, 2. Our original graph had a y-intercept at 0, -1. And our inverse, -1, 0. Look at that. All right. Let's see. We had an x-intercept in the original of...
The other one.
Oh, it's the other one. Okay. -0.236, and here is 0, -0.236. So again, we see perfect matches there. And finally, we have our other two y-intercepts right there, 4.236, 0, and 0, 4.236. So you have done it. You have found a beautiful inverse. Wonderful, wonderful, wonderful. Well, now, one way I was kind of nice to you, I already wrote this problem as a square, so it was really easy for you to use square root to make the square go away.
Yes.
What if I was just a little bit meaner?
Oh.
What if I did that? X squared minus 6x plus 9. Is there a way that we could take this and make it look like a perfect square like the previous problem?
Yes.
Okay, what do we do?
Factory.
Okay, so tell me about that.
Okay. So.
Is this a perfect square already, or do we need to adjust it? How can you tell?
Well, this plus 9 is whatever number is going to be in front of x squared. And so that would be 3.
So you're telling me that I want to think of this 9 as 3 squared?
Yes.
Okay.
Okay. So with that being the case, the numbers in the parentheses is going to be x and 3 in both. And luckily 3 and 3 combined makes 6.
So if I'm understanding what you're telling me that we're going to get -3 twice.
Yes.
And that's where that -6 is coming from.
Yes.
Okay, so if that were so, then how could we rewrite this as a perfect square? So this formula that I gave, x squared minus 6x plus 9, can be rewritten as x minus 3 perfect square.
Yes.
And so now would you find the inverse from there?
Yes, sir. X would now equal y squared. Get rid of the squared, find the square root of both sides. Square root of x equals y minus 3. Add 3 to both sides. You have y equals 3 plus or minus the square root of x. So then you would have to split those into two formulas when using the calculator. So y equals 3 plus the square root of x, and and y equals 3 minus the square root of x.
Okay, well, let's see if she's right. I have graphed the original formula on Desmos. Here is the original formula, x squared minus 6x minus 9. And I'll go ahead and zoom in a little bit better so we can get a good look there. There she is. And I have typed the two formulas you gave. 3 plus the square root of x, 3 minus the square root of x. And let's see how they look. Pop, pop. There in blue is the positive square root, 3 plus root x. Here in green is the negative, 3 minus root x. Do we have a good match? We sure do. Here's our vertex at 0, 3. And here's the inverse vertex at 3, 0. This one's opening up, this one's opening to the right. Looks like we're doing great. Now, you may not realize, folks at home, but I was actually being nice again, because I gave Tiara something that was already a perfect square. But what if I was even a little less nice and I gave her something that was not a perfect square? Well, not to worry, folks. Don't worry. Tiara's worried, but we're not going to worry. We're going to figure out what would make this become a perfect square. So what we're going to do is we're going to rewrite this as y, and then we're going to put a blank, x squared minus 12x plus blank. Now,
Yes.
we want a number here that will make this a perfect square.
Yes.
Can you tell me what number would go there and why?
36.
Okay, 36. Why is 36 the number we need?
Okay, 36 is basically 6 squared, and so you have...
Okay, now where are you getting 6 from?
6, because I need, whatever number is right here needs to be double the next number.
So just like before we had 2 times 3?
Yes.
This time you want me to rewrite 12 as 2 times negative 6.
Yes.
Is it always going to be 2 times?
Yes.
It's always going to be 2 times?
Well, not always.
Yes,
but
always.
In this case, it is?
Always.
Oh, that's made me question myself. Okay.
See, I got her. All right. So we got negative 6, and then what are you going to do with that negative 6?
Square it.
And so squaring negative 6 gives you 36 as you promised. Okay, now folks, I can't just go scratching out 12 and writing 36. I got to do something. What can I do to 12 to make it into 36?
You can add 24.
I can add 24. And if I'm going to keep my equation balanced, I can totally add 24 here, so long as whatever you do to one side, you must do the same thing to the other side. So I must add 24 here as well. So now we have y plus 24 equals a perfect square. And what is that perfect square, ma'am?
X minus 6.
X minus 6. Remember, dividing by 2.
Yes.
Minus 6. Hey, that's written as a perfect square. Can you take it the rest of the way?
Yes.
Cool. Show me that inverse.
Okay. Plus 6 plus 6 y equals 6 plus or minus the square root of x plus 24, and then you split those into two equations again. So y equals 6 plus square root of x plus 24, and it also equals y equals 6 minus the square root of x plus 24. There we go.
Okay, folks, let's see if she's right. So here is the original graph. X squared minus 12x minus 12. You'll notice, folks, I had to zoom in quite a bit because the y-intercept is at negative 12, and the vertex is way down here at 6, negative 24. And again, I'll just click on that right there. There's the vertex, as I said. It's at 6, negative 24. Now here comes the inverse as Tiara told me. Notice again in blue, there's the positive square root of x plus 24. Here in green, negative square root of x plus 24. We know this point right here is 6, negative 24. 6, negative 24. And let's see if we have a match. Negative 24, 6. Beautiful. Let's check the y-intercepts. Here I have a y-intercept at 1.1, 0. And here I have an intercept at 0, 1.1. Beautiful. Let's see, I have a y-intercept here at 10.9. And I have, let's see if I can find it. There we are. So look at that again. Very nice indeed. We have found our match. All right. Well, I don't know if there's anything else mean I could do to you. I take that back. I know one more mean thing I can do to you. I could make the first number not be a 1. That's the other thing I could do. I could make the first number not be a 1. Okay, so what are we going to do about a situation like this? Well, here's what we're going to do. When the first number is not a 1, things are very mean. We're going to get this 13 out of the way because it's just going to clutter things up by subtracting 13 to the other side. So we have y minus 13 equals 3x squared minus 6x. Okay, now that 3 is a troublemaker. You might want to divide both sides by 3, but resist that urge. Instead, you want to factor the 3 out. So we're going to leave this side alone right now, y minus 13. But here we're going to take the 3 out. Now if I take that 3 out, that's like dividing. So 3x squared divided by 3 gives me x squared. Negative 6x divided by 3 gives me negative 2x. And then we're going to have, and that filler is going to be what?
This filler is going to be 1.
Plus 1. Okay. Now you got to be careful. She didn't really add 1 there.
I did not. Technically plus 3.
Technically plus 3, and I'm going to explain why in a minute. But first, let's make sure everybody knows why there's a 1 there. Remember, it's always divide this by 2. So it says negative 2. We're going to think of that as 2 times negative 1. So negative 1 is our number, and you have to square it. Negative 1 squared gives us 1, and that's how she knew to put a 1 there. But that's not really a 1 because this 3 is distributing. So that's actually 1 times 3. And so we added 3 there. So to balance the equation, we have to add 3 here. And so now what we have is y minus 13 plus 3 gives us y minus 10 equals 3 times the perfect square of x minus 1.
Yes.
There we go. So that's what you do if the lead number is not a 1. You first move any constant to the other side to get it out of the way, and then you factor out the lead number. Now once you've got that, why, it would be very easy for Tiara to find the inverse.
Which I'll do now.
Which you will do right now.
Okay. 3. Supposed to be y. Okay. Square root, both sides. Cancel. Square root of x equals y minus 1. Add 1. Y equals 1 plus or minus the square root of x minus 10 over 3. And then split those into 2 equations. So you can plug it into your calculator. You get 1 minus the square root of x minus 10 over 3. And y equals 1 plus the square root of x minus 10 over 3.
All right, folks, let's see if she's right. Here is the original graph. X squared, 3x squared minus 6x plus 13, here it is. The vertex is located right here at 1, 10. The y-intercept is at 0, 13. And I have copied down the inverses she gave me. Let's see. The vertex here is at 110. The vertex here is at 10, 1. The y-intercept here is at 0, 13. The x-intercept here is at 13, 0. Looks like we've got a match. So folks, now that's how you find an inverse of a quadratic. Well done, ma'am.
Thank
And
you.
folks, now it's your turn.